Hello, I'm Nutan. This is our project. Our project name is Version Vault. It is a Git-like version control system in C++. Version Vault is a custom-built minimalist version control system inspired by Git. Our project is entirely in C++. Uh, Here, apart from Git's essential concepts like staging, commits, branching, checkout, merging, deterministic hashing, snapshot-based versioning, we use some specific extra tools like cherry picking, uh, merging, etc. We also used data structures and algorithms.
Okay. Uh, this exe file is the file that I have compiled from the project. This is the project, and I have compiled it, and we got execution file. I have pasted it here, and this is the test file that I will be working on. So let me initialize a repo. Yeah, main branch is created right now. This is actually a hidden file, but I can see it in Visual Studio Code. So these are all the commits, and this is the staging area. And let's add my code. You can add all files or just type the file name here. See in the staging area, the new file is added. Let's just commit it. You will see a new file is added. See the code is completed here. And let's just change it. You will see staging staging area is again updated. And let's just commit it. Yeah, it is completed. So this is the second commit. Second commit. See second commit like so the code is updated. And to check the commit details of the main branch, we use log. See, first commit always comes at the bottom, and the second commit, and then if we add the third commit, it comes at the top. This is connected as linked list, so it will always come from the recent one. Let's just add the third one. You see, it is forced from the same third commit, and let's print the log. See the third commit appears at the top, and now let's create a branch. The branch name is dev, and let's switch into the branch. Now we are switched into the branch. Now all the commits that we are doing right now will be only in the dev. So this is the first commit in dev. Let's change it. Let's do another commit. Now let's see the log of dev. In the log of dev, you can see the commits of the main and as well as commits of the dev. But let's just switch to main right now. But in the main, you can only see commits of the main. See only three commits. And let's use merge right now. What merge actually does is it takes the latest commit from the dev and makes it as a new commit in the main. Now let's see how many logs in the main. See, you can see four. The fourth one is match branch dev. If you check, the code will also be same in the 25320 and the latest one in the is the second commit 3C82B310. You see here 2520AD and 3CM. See this one and this one both have the same code. Now let's use revert. What revert does is in the same branch as main, it takes any previous commit and commits it as a new commit. So the code will be same, but will be a new commit. And what is cherry pick is it takes any commit from another branch and make it as a new commit in the main. Let's use it. Let's take any commit from let's say first commit in the dev, that is 5D1. Yeah, cherry commit from 5D8 and the new commit in the main is 852. If you check it, the 852 code and the 5D code. See, both were same. So this is our project and this is our project demo and my friend Ashish will explain the rest.
Hello guys, I'm Nutan and I'll be explaining about git merge and git cherry pick. So what merge does is it will take the recent commit from the another branch other than the merge main or other than the main and merge into the newer commit of the main. So and what cherry pick does is, let's say we don't want the recent one of the another branch, we want we know the commit id and we want that commit to be the newer commit of the main, then we will use cherry pick and then we will use the id of that commit, so that will be the newer commit of the main branch. So that is why we use cherry pick. And merge is for only the recent commit of the developer branch or the any another branch other than. Hello, this is Pawan again, and I'll be explaining my part of the contribution in this code. uh, I'll be explaining you git add, git branch, and git checkout, and git current branch. So let's get into about git branch, git add. This function performs selective staging for every file name the user provides. Like it behaves exactly like git add file 1 file 2 where only selected files will be staged to the staging area. And let me explain also the git branch. So a branch in my system is just a file inside git references. It will be like main and the new branch is dev, like that. So my new branch simply points to the same commit exactly like git's real branching model. And the checkout is for After checkout, my new commits update the branch pointer. I don't swap working directory files, keeping the implementation simple and clean. Like I overwrite git head with reference to another branch. Like in the head, the reference will be like reference heads and then main dev. And if I change it, it will go to dev instead of main. And let's check the current. The current branch is that this function reads the head file. As I said, in the head file, it is stored that the path of the branch, like reference and then slash head and then slash main. So the current checks what is the end of this path. If it is main, it will tell you main. If it's dev or any branch name, it will tell you that where are you in right now. So thank you, and my friend Ashish will continue.
My name is Siddharth. I have contributed in this project by making some header functions and SHO algorithm with some helper functions. So my part of the project deals with generating the commit hash and managing the branch references. So first I generate commit hash by our own custom SHO algorithm, which you can see here. And I have first I generate the commit hash using our SHO algorithm implementation. I fed it to the parent hash, the commit message, which is visible right on the screen right now. Here you can see that the parent hash and the timestamp, the commit message, everything, and the path plus content of every staged file. This produces a unique deterministic 40 character commit ID. Second, I handle the write head reference function, which I have created here in the git class CPP file. So you can see here right on the screen that I have used a write head reference function which sets which branch is active, and get head reference local which reads it, and you can see the set refer value local, which is this function which is visible on the screen right now, which updates the branch with a new commit hash. So together this part of code creates a commit ID and updates branch, so it points to the new commit, and this completes my module.